We're on lesson 4 of chapter 3, which is operating with scientific notation. First we're going to divide with scientific notation, then we'll multiply with scientific notation, and then we'll add and subtract with scientific notation. Here we have two numbers in scientific notation. We have 4.2 times 10 to the 7th, and we have 1.4 times 10 to the 5th. And when you do math problems with these two numbers, some people find it pretty daunting because the numbers are pretty large and because it's written in a format we're not really used to, which is scientific notation. When you come across these problems with multiplication or division or addition and subtraction, there's different ways you can go about it. To perform multiplication or division with numbers written in scientific notation, you could perform the operation in two parts. And here's what they mean by that. We have 4.2 times 10 to the 7th divided by 1.4 times 10 to the 5th. You can deal with the regular numbers by themselves, and you can deal with the powers by themselves, and then put your answer together to get your answer. 4.2 divided by 1.4 is 3.0. 10 to the 7th divided by 10 to the 5th, as we learned in a previous lesson, is 10 to the 2nd. So therefore, 4.2 times 10 to the 7th divided by 1.4 times 10 to the 5th is 3.0 times 10 to the 2nd. Addition and subtraction take a little bit more work actually. When you have addition and subtraction with numbers in scientific notation, you need to perform the operation with common powers of 10. And let's go over to this chart to help us a little bit. We know that 2.54 times 10 to the 6th is the correct way of writing scientific notation, with only a number in the ones place. But there are other ways of showing the same number, and we're going to need to do that for these problems here. See, I can make this number 24.54, move that decimal over, and since I made this 10 times as big, I need to multiply it times 10 one less time. So a way to think about that is if I make this number 10 times bigger, I need to make this 10 times smaller, or drop the power one. The opposite is true as well. Here I made this 10 times smaller than this one, so therefore I need to multiply this times 10 one extra time to keep this being the same number. So for example, we have 4.2 times 10 to the 7th minus 1.4 times 10 to the 5th. These need to be common powers of 10. So therefore, this number needs to become 2 bigger, meaning I need to make this 2 powers of 10 smaller, or divide it by 10 2 times to make this equal 7. Then since these are the same, we can leave this as is, and then subtract the decimals to get our answer. We'll go through these in a little more detail with some practice problems. First, we're going to divide with scientific notation. Here we have a list of the mass of planets in the solar system. So going in order from closest to the sun to farthest, we have this list here in scientific notation. It asks us how many times greater is the mass of Jupiter than the mass of Earth. Write your answer in scientific notation. So whenever you see these words, how many times greater, we know that's a division problem. So basically we're asking how many Earths can fit into Jupiter, which means we take Jupiter divided by Earth. Well, Jupiter is 1.89 times 10 to the 27th power over Earth, which is 5.97 times 10 to the 24th power. So just like we showed here, we could treat them separately with multiplication and division. So since we're dividing, we could treat these separate, and we could treat these separate. So 1.89 divided by 5.97, 1.89 divided by 5.97, that gives us an answer of 0.3166, we'll say. Now we can deal with these ones here. 10 to the 27th divided by 10 to the 24th. We learned in a previous lesson that you subtract the powers here. So that becomes 10 to the 3rd. So here's our answer. 0.3166 times 10 to the 3rd. As we learned with scientific notation before, this is not a correct answer. We need to move this over 1 to become like this, and since we made this 10 times as big, we need to make this 10 times smaller, so make this 1 less power of 10. So if we do that, we move this 1 over, making it 3.166, and that'll be times 10 now to the 2nd power. So Jupiter is this many times greater in size than the Earth. Now we can multiply with scientific notation. It says the mass of the Sun is approximately 3.1 times 10 to the 6th power times greater than the mass of Mars. It says find the mass of the Sun and write your answer in correct scientific notation. Well, if we have the mass of Mars and it's that many times greater than it, we need to multiply Mars times the Sun. So we have 6.42 times 10 to the 23rd and that's times 3.1 times 10 to the 6th. Same rules apply for multiplication and division. We can multiply these by each other, and we can multiply the powers of 10 by each other. 6.42 times 3.1 would give us 19.902. 19.902. So now what power of 10 are we multiplying that by? We have 10 to the 23rd times 10 to the 6th. When you multiply powers, you add the exponents, so that'd be times 10 to the 29th. Hopefully you recognize that this is not correct scientific notation. We need to make this 10 times as small, or move this decimal over one place. So since we made this 10 times as small, we need to multiply it times 10 again, making this 10 to the 30th power. So 1.9902 times 10 to the 30th power. And then the mass of the sun would be measured in kilograms. Now we can add and subtract in scientific notation. So it says the mass of the moon is about 7.35 times 10 to the 22nd kilograms. Find the approximate combined mass of Earth and its moon. Write your answer in correct scientific notation. So it tells us to find the combined mass, and whenever we see that word combined, that's going to tell you to add. So we're looking for Earth and the moon here. Well, the Earth is 5.97 times 10 to the 24th. And we notice that the moon does not match up with the power of 10 for this one, and we said that with addition and subtraction they have to have common powers of 10. So there's two ways you can do this. We can drop this down to 22 by changing this around, or we could change this around and make this times 10 to the 24th. Here's a little hint for you. It's almost always easier to make the number bigger to match this one. So let's do that. We have 7.35 times 10 to the 22nd. We want this number to go up, so therefore to keep the number the same, this has to go down. If we divide it by 10 twice, so 0.0735, since we divided by 10 twice, we can now multiply 2 more times 10. So times 10 24 times instead of 22 times. So here's our new number, 0.0735 times 10 to the 24th. So that's what we're adding here, plus 0.0735 times 10 to the 24th. Since we're adding, we don't do anything with the scientific notation part, but we do add the decimals. 5, 3, 14, add that, making it 10, drop the decimal. So we have 6.0435, and that's in correct scientific notation, times 10 to the 24th. So that's how many kilograms combined the Earth and the Moon would be. Now it asks us to find how much greater, that means it's going to be a subtraction problem, is the mass of Neptune than the mass of Venus. So how much greater is Neptune than Venus? So we would subtract Venus from Neptune. So Neptune is 1.02 times 10 to the 26th. Venus is 4.87 times 10 to the 24th. So since these don't match up, I have to change one of them. Remember, it's easier to make this go up than it is to go down. So to make this bigger, we need to make this smaller. I need to get 2 bigger, so let's move this over twice. So that's like dividing it by 10 2 times, and since we divided it by 10 2 times, that means we can multiply it times 10 2 more times. So here we have it. We have 1.02 times 10 to the 26th power minus 0.0487 times 10 to the 26th power. We're going to subtract here. Let's add a couple zeros. So we'd cross a 2 out, making that a 1, making this a 10, making that a 9. 10 minus 7 is 3. 9 minus 8 is 1. We can't do 1 minus 4, so let's cancel this out. So we have 11 minus 4, making a 7. Then we have a 9, point, and a 0. So 0.9713 times 10 to the 26th. We know this is not correct scientific notation. We need to multiply this times 10 to make it correct scientific notation, which means we multiply it times 10 one last time over here. So we move that decimal over, giving us 9.713 We multiply times 10 one last time, so times 10 to the 25th.